Welcome to the Genius Factory. Enjoy the video.
You start by gathering parts and making the first connections. Attach the GPS module to Arduino TX/RX and share ground. Make sure voltage levels match. Many modules need 3. 3V. Insert an activated SIM in the GSM module and wire its serial pins to a spare Arduino RX/TX using software serial. Once done, power from a LiPo through a regulator and confirm the IDE recognizes the board. This gets your hardware responsive. Next, you will read location data and prepare transmission logic. Now you implement parsing and data formatting. Use tiny GPS++ to extract latitude and longitude from NME sentences. Check for a valid fix before sending. Buffer serial input to avoid dropped bytes and convert coordinates to decimal degrees for precision. 5 or more decimal places yields meter-level accuracy in many cases. Build a compact payload, for example JSON with device ID, UTC timestamp, lat lon, and altitude, because compact messages reduce GSM cost. Once formatted, queue the payload for transmission via the GSM module. Finish by transmitting and validating delivery. Initialize the GSM module with commands, confirm network registration, configure the APN, and use HTTP post or SMS to send the payload. Check response codes and clear buffers. Implement retries with exponential backoff and store unsent messages to EEPROM or SD so you don't lose data. If something fails, first check antenna placement and signal strength. Make sure GPS has clear sky view, verify SIM data balance, and watch serial logs to pinpoint the issue quickly.
Thanks for watching. If you found this helpful, don't forget to like and subscribe.